As you build applications in Python, you're probably going to find that you use databases quite a bit. And so you'll probably find some value in having a normalized interface for working with your databases. I've built such a normalized interface, and you're welcome to use mine, but I would suggest that you simply use this as a model and build your own. Build one that works for you, that works for the way that you like to work with databases. So I'll show you mine as an example. It's called bwdb.py, and it's in the lib folder in the 19 projects folder in your exercise files. So we'll go ahead and open that up, and we'll maximize this so that we can take a look. Of course, it imports SQLite 3. This is a library for using SQLite 3. Like I said, for most of my web applications these days, I'm using SQLite 3 because it's small, it's fast, it's self-contained, it's easy, and it's very robust and reliable. Never had any problems with it. So there's a class here called bwdb, and the first thing in it is the constructor. And the constructor simply takes this keyword arguments and it looks for the file name and the table name. You'll notice that in each of these methods, I have what's called a doc string. If the first line in a function or a method is just a string by itself, this is picked up by Python's documentation protocol, and it's called a doc string. I use it to describe how the function works. This is the constructor method. The table is for the CRUD methods, and you don't have to use that, and we'll get to that in a moment. And the file name is for connecting to the database file. Here is one of my workhorse methods. It's called SQLdo. This is for non-select type queries. You just pass it in some SQL, you pass it in some parameters, and it does its job. This next one, SQL query, is the same thing, except that it also works as a generator, and it'll iterate through a set of results. And of course, each result is a row factory. And you'll notice that the constructor assigns file name here, and file name is actually a property which is defined down below. We've seen this technique already. And so in the setter, when a file name gets assigned, it sets the attribute in the object. It also connects to the database, and it sets up the row query. So this is actually a constructor of sorts, but it allows you to change files if you want to. If you're using the object and you decide that you need to assign this object to a different database file, first, of course, it'll call the destructor, which closes the old database, and then it'll call this constructor for the file name, and it'll connect to the new database. This works really, really well. We have an SQL query method for returning a single row, and we have an SQL query method for returning a single value. I find these very useful, and I use them a lot. Again, depending on how your pattern of dealing with databases is, you might find different things useful, and I would suggest that you use those. Now we get into the CRUD methods. CRUD stands for create, retrieve, update, and delete. These are the basic 4 functions of a database. And so this is the getRec. This would be the retrieve part of CRUD. And for my CRUD methods, I depend on there being a column in the table that's called ID. And so all of my tables and all of my applications that are going to use these methods must have a column called ID. I typically create this column in SQLite using the integer primary key feature, which makes that column an equivalent for SQLite's internal row ID. This all just works very nicely together, and you'll see examples of this in the projects that we're going to look at in this chapter. GetRex is a method that returns all of the rows in the table, and it returns it as a generator with row factories. Insert inserts a record, and this uses a dictionary for the record. This is actually very interesting. This method constructs the SQL based on the names of the keys in the dictionary object that gets passed. So it takes a little bit of care to work with it, but when you use it with care, it works very, very well. This next method works the same way. Again, it constructs the SQL query based on the keys in the dictionary object that gets passed. And this will update a particular record based on an ID that's passed. And finally, we have the delete method, where it deletes based on the ID, deletes the row from the table based on the ID, and a countRex method that simply gives us a count of all the records in the table. This is a very fast operation to do in SQL. Most database engines, including SQLite, are very highly optimized for count operations. So this method offloads that work to the database engine and allows it to happen very quickly. Finally, we have the property accessors for the file name property and a close method for closing the database. Then we have a test method for testing, and we'll go ahead and run that. And that creates a database in memory. SQLite has a feature where if you give the file name as this with colons on either side of it, that whole thing is the file name, then it will create a database in memory. Creates a table, inserts into the table, reads from the table, updates the table, exercises all of the CRUD methods. So that is my example of a normalized database interface. I find this very useful, and you'll see an example of it here in this chapter of how I use this. It makes it that much easier for me to work with databases in my applications. And these days, in the little web applications that I might be working on, it saves me a lot of time and work and allows me to focus on the logic of the code.